Everybody. My name is Tim Buffkin. I'm the National Sales Manager for Broadband NCAP America. Wanted to welcome everybody and thank you for joining NCAP America's latest webinar. And this is a new one for us today. We're going to be going over air-jetted cables, going over the cables, the technology behind it, or micro cable as well as a lot of people call it. So we'll get going. To start off, just to let everybody know, we are RCEP compliant. We do meet the standards that you can get continuing education credits. So if you do have any questions, you can go online. We'll have a quiz that'll follow this presentation that you can take to get this continuing education credits. So here's the links here. If you do have any questions, feel free to let us know. So what we're going to do today is, again, we're going to talk about the basics of a blown cable network, right? What are the benefits of deploying this method, as well as talk about the more technical details of the cable itself. And then we'll basically just look at the different designs and configurations of these groups of cables, and then really talk about, how this kind of deployment can speed up your network build, help save you money, and what the benefits are of not only this type of cable, but using this type of network in your build as a whole. So again, this goes along with the RCEP. After this, we'll have a basic understanding of what a blown cable network is. Again, talk about the importance of selecting the correct cable diameter in relationship to the duct. Talk about the benefits of the network again, but also the difference of the footprint between standard cable designs and blown cable designs. And then talk a little bit about when it's beneficial to deploy this type of a network. So the schedule for today, we've had the introduction, sound check. I haven't seen anything pop up in the chat, so I'm assuming everybody can hear me well. The presentation itself is going to last about 45 minutes. And then during that, if you want, you can use the chat function to ask any questions. I'll probably get to most of those towards the end just to keep it kind of clean. And so the last 15 minutes or so, we'll do a Q&A. We do ask that you keep the Q&A session to questions regarding this presentation. If you do have any business related questions, we can take that offline afterwards. So with that said, we'll get going. So blowing technology, right? What are we talking about when we say that we're talking about blowing cables or blown in cables? So blowing, you can also use the terms jetting or floating. That's basically just the term of the technique that we use when installing cable into duct by using the force of moving air, right? Blowing, you're blowing air into a duct that's going to help move the cable down the duct. Obviously, with your standard cables, your standard duct type cables that a lot of people use, usually you're going to use some type of a pull string or something along those lines, and you're going to, from your end to destination point, you're going to pull from the beginning to the end, but you're going to pull from the area that you're ending up at. Whereas blowing, you're going to start at the beginning and your equipment is going to be on that side. So we're going to use that air to lift the cable away from the duct walls, which is going to lower friction for us and allow us to go a lot farther than you can with a traditional pulled type of an install. The speed of the install is also going to be a lot higher, again, because of the reduced friction with these types of cables. So you can see speeds of anywhere up to 196 feet per minute, right? And there's a lot of different factors, and we'll go into some of those that can affect the speed. But generally speaking, 196 feet per minute on the install compared to a traditional cable and duct setup, you're going to be somewhere between 50 to 100 feet if you're pulling the cable through the duct. The other great thing about this type of cable and this type of network is it's going to optimize your footprint. It's going to lower your footprint, lower the size of the cable, the weight of the cable. It's going to lower the size potentially of the duct that you're using. But that's also going to translate to everything else in your network as well: splice enclosures, handholds, pedestals, things of those nature. So it's going to overall drop the footprint of your entire network. But also, since we're using a smaller cable, lighter weight cable, you're also going to save on logistics. You're going to save on freight. Just think about being able to fit more cable onto a single truck, right? That's going to help lower the cost of your freight and your transport. But again, also just helps on manpower. You're not handling, you can get away with using smaller reels that are just easier to handle. It's just overall just an easier cable and network equipment to transfer. I mentioned the hand holes or the vaults that you might use. Again, since it's a smaller cable, you can use smaller vaults. So maybe instead of using a big 30 by 48 vault, maybe you're only using a 17 by 30. So again, smaller box, lighter weight box, easier to put in the ground. Cost association from a standpoint of just material, but also from the labor to install that as well. So again, talking about the principle of what we're doing, we're blowing a cable into duct. So if we're looking at this picture here, and essentially our starting point, and we'll assume that our reel of cable is sitting off screen to the left, right? So that's going to be where you're starting with your reel of cable. From there, you're going to go into the drive wheels, and what you're going to do is that's going to push the cable a few feet into the duct, right? So you're pulling it off of the reel and then getting it started into the duct. From there, what we're going to do is we're going to increase the air pressure at the blowing head until we get a steady airflow that's achieved at the end of the duct of where we're going. And then essentially what's happening from there is as that the drive wheel starts to push the cable into the duct, the air is then taking over after that few feet in, and then it's pushing it the rest of the way. And then that air, again, as we talked about in the last slide, that air is helping keep that cable off of the inside of the inner duct. And then from there, it's once the drag forces from the moving air increase in the cable, you can keep ramping that speed up quicker and quicker. Obviously, there does hit a point to where the cable weight, the friction that's being created, and the air drag forces do reach a point to where, you've kind of hit the end of the road. But in essence, in basic terms, this is what blowing cable looks like. Again, you're starting at the beginning and you're pushing and then blowing the cable to your end destination. So we talk about distance. What can we really achieve in terms of how far we can have that cable go? Again, it really just depends on a number of factors. And so we'll talk about one factor that I'll hit on a bit more in detail. It's going to be the ratio of the outer diameter of your cable to the inner diameter of the conduit. The other thing is going to be, what does the route look like? You got this, this bird's nest on the right of this microduct. Obviously, that's a worst case scenario. The more turns, the sharper the turns and the bends, things like that. It's all going to affect how far and how quickly you can deploy that cable and blow it through that. So, if you're looking at an extreme route with a not ideal diameter between the cable and the duct, and something on the right where you've got a lot of bends, a lot of sharp bends, you could see something as low as 1,600 feet on a single run, with an average speed of being 160 feet per minute, or potentially a little bit lower. Now, if we're looking at a normal installation, typical route, we're looking at a better diameter ratio between the cable and the duct. We can see 5,000 to 6,000 feet out of a single run, which is again, right. We talk about a cost standpoint. If you can go 6,000 feet on a single run versus 1,500 to 3,000 when compared to a standard cable and pulling it through a duct. If you can go that and your network calls for runs that can work that long, all you're doing is you're decreasing the amount of times that you have to install a handhole or have to put a junction box, a splice enclosure, or splice point, whatever that might be. You're going to decrease that type of equipment. And again, obviously, the different scenarios and different things can all vary, right, case by case. It is very much a case by case basis. But again, 6,000 feet is typically going to be about your longest run. Probably under certain scenarios, you could probably bump that up maybe to 6,400, 6,500 feet. But 6,000 feet is going to be on an ideal scenario, where you're going to typically max out. So again, overall, what are the benefits of going this route? We talked about the cables being lightweight. They're a lot more flexible. You're going to get away with a much smaller bend radius out of this than a traditional cable. So really, it makes it a whole lot easier to fit this cable and fit this duct into areas that maybe do have some limitations in terms of what you can put in the ground. And again, the flexibility of the cable, I mentioned handholds or the vaults earlier. Being able to take let's say a 288 fiber cable, and that's in a standard design. Again, something like that, you're probably going to need a larger, 24 by 36 or a 30 by 48 vault to be able to put your spare cable in. However, with the micro cable, because it is more flexible, again, you can go with something that's more along the lines of a 17 by 30, right? So you get a lot of flexibility from that standpoint. Also, it gives your network more longevity and flexibility. And I think, to me, the flexibility here is a big part of it, and that's because of pairing this cable with a micro duct. And there's many companies out there that make duct. They have what's called a multi-duct or a multi-path. And in essence, what you're getting is on the outside, what looks like a single duct bank. On the inside, you can have 2, 4, 8, 12, 16 individual duct banks. And these can be a mix of standard duct, micro duct, right? Different diameters of each. But what that does is, when you're putting your duct into the ground, now instead of just having 1 or 2 ducts, you can again have up to 16 duct banks that you can go and blow more cable through. And when we talk about planning and being able to expand your network, it's I've talked about it in the past. It's important to to plan for the future, right? So just like you want to plan ahead with your fiber count, this gives you the ability to be able to also plan ahead with how much duct space you've got in the future and how much you'll be able to use. And again, everything, right? Fiber to the home is blown up across the country. Appliances in your house are all becoming Wi-Fi connected. So again, it's important to think about, as the technology is increasing our demand for fiber, you've got to just, again, make sure you're planning ahead. And this just makes it a whole lot more of a simpler way to be able to expand your network down the road. Again, we talked about the long installation distances, right? So we're saving on enclosures, saving on handholds, giving you a lot more flexibility from that standpoint. And again, just the installation time, right? So if we're comparing this to a standard dielectric cable and an inner duct that we're pulling, the time to install the duct, whether it's a micro duct or a standard cable duct, that's going to be essentially the same. You're either boring or you're trenching duct into the ground. That part's not going to be different. But again, it's the part of actually installing the cable that's going to save you a lot of time. Again, I said it's 196 feet per minute is traditionally about the speed that you're going to have on a regular route, without a lot of turns and things like that. When you're pulling cable, you're typically running somewhere between 50 to 100 feet per minute. So again, depending on the scenario and where you're at, you're talking potentially 4 times the speed difference between pulling cable through interduct and blowing it. And that, of course, obviously through, if you're an electric utility or you're somebody that's starting a new fiber to the home build, that footages and that time, that definitely adds up. And again, we talk about the size, right? And that's, again, I'll probably say it 30 more times during this presentation. The size of the cable is what makes this such a great cost saving product in a cable, because you're 60% smaller and lighter than your traditional duct and direct buried cables. And then again, we talked, touching on the duct, it's 5G is becoming so large right now, and you've got smart cities, you've got surveillance, you've got so many different needs that are getting added onto these fiber networks. I can't stress enough, being able to look forward and see what you might need down the road. And again, you plan ahead. This just gives you so much more flexibility and ability to grow your network down the road at a much lower cost. So we've got here, when we're talking about the different, the different configurations in terms of the cable diameters, the duct diameters. So really cool. It's a great picture of a blown in cable test track. And really here's what we're looking at is how far can we get these cables to go? You've got the track length up to about 6,500 feet. And all we're doing here is looking at, okay, with outer diameter of the cable, with a x diameter inner diameter of the microduct, what does that look like in terms of blowing, right? What are the different jacking materials? How does that affect it? You've got a couple great companies that do stuff like this, and really gives us a lot of feedback on really what can be done, with this type of cable. So things to consider, right? So traditionally, at in-cab and the customer base that I've worked with a lot, it's a lot of electric utilities, right? Of course, the big push right now is a lot of the EMCs across the country, the public power distributors that are getting into the fiber to the home network. So the main question there is going to be aerial versus underground. Are we going to put cable up on the poles, or are we going to go below ground? I've said it before in previous webinars. If you are an electric utility, ADSS is almost always going to be the most cost-effective option for deploying a fiber to the home network, and really just installing fiber to begin with. You've got the crews that can hang it up. You don't need as much machinery. Again, that's going to typically be the best option. However, if you do have areas that you are going to go into that you have to be below ground, you want to look at population density, right? How many people here am I serving? Again, what's the potential for growth down the road? Again, I talked about 5G, right? Dark fiber, but also too with doing the multiple ducts in the ground, you can also lease out the duct space. So again, if you put call it 12-way duct into the ground and you're only using one of them, if a 5G provider comes along or a long haul provider and they want to pass through your network and get from one side to the other, they can just lease out the duct space, they blow it through, and then you're not having to mess with the fiber. And so not only do you want to be able to anticipate your network needs, you want to give yourself room there to also have an extra source of revenue. Again, on the 5G, I've talked to a lot of different companies that, some of the cell carriers, they don't necessarily want to go put fiber in the ground themselves. If you've got fiber, they just soon come to you and say, hey, we'll pay you X amount of dollars a month. Give us, these amount of fibers in this area, and then let's go. It's easy for them because they don't have to mess with the install. But again, it's great for you because it's another source of revenue. So the other thing, outside plant enclosures, right? So I mentioned how obviously we're going to a smaller cable. So we're going to go to smaller splice enclosures. To me, I try to preach to everybody, see what's out there. Just because of the enclosure that maybe you've been using, or somebody that they've been using the same enclosure for the last 20 years. When you do go to something like a micro cable, there might be other things out there that work better with a micro type of cable. And there's a whole lot of different attachments and things that really work well with micro cable. Even to an extent, I know I've seen certain enclosures that you can actually blow the fiber straight directly into the enclosure, right? So it's important to keep an open mind. And I know there's a lot of different enclosures that kind of seem just to be the default. But again, I encourage you to explore, see what all is out there, because at the end of the day, you want to build the network that is right for you, and what you're going to be comfortable with using down the road. And a lot of the different outside plant type enclosures, a lot of companies make some really good product, but a lot of it really just kind of comes down to preference. Also, if we're looking at a rural setting versus an urban setting, if we're in an urban setting, we're in a downtown environment where you don't really have a lot of right of way where you can bore or plow, you might look at something like micro trenching. So if we look at the picture on the right side here, essentially what we're doing with micro trenching is, in really basic terms, we're taking a big concrete saw and we're going to cut into the road right by the sidewalk. and then that's going to be our path that our cable is going to take. So typically what you're going to do is you'll cut about 12 inches into the ground. You'll lay, multiple pipes on top of that. And then there's, it's a mix of, like of polymer and fillers that's going to go around the duct and fill it up to fill in that hole that you just created. So especially, and the great thing about this is you can actually cover a pretty solid distance decently fast with putting the duct in the ground. And again, the other thing is in a downtown setting, you may not have many other options that are going to be very cost effective. So in the right setting and depending on your environment, where you are, what your options are, I've seen numbers that can drop your installation cost by as much as 60 to 70%. But again, it's right. It's all relative on what your network looks like and what you're trying to accomplish. But again, micro trenching is a great option. It's starting to pick up a lot more momentum, I'd say, over the last 5 to 10 years. There's some companies out there that make some great machinery that have really done a lot of work on figuring out how to make this a lot more efficient. Another area where this might be beneficial as well is, let's say if you're in a high-end neighborhood and the people there, they don't want boring machines in their yard. They definitely don't want trench machines in their yard, right? There's limitations there that maybe you can't get around. This again can provide a much better option and still a very cost-effective way to be able to get that duct in the ground, right? So again, the cable is going to go in the same way. It's just about how we're going to go about doing the duct. Because obviously in this scenario, you're not going to go and cut out a 4-inch, 5-inch wide hole that you're going to lay multiple standard ducts into. So again, just another great option, I think, that in the right settings can really help speed up the install process and help save you a considerable amount of money on the install as well. All right. So now we're going to move to the actual, just the cable itself. We're going to talk about what makes up the cable, the design, what our options are when we're solely just looking at the cable. So the main features, again, I've mentioned it's the outer diameter is going to be the first thing that everybody notices. Here we've got our two cross sections of what's our standard 288, what we call our duct cable. It's a dielectric, non-armored, standard cable that's going to get pulled through your inner duct. And below is going to be one of our blown-in designs. Again, same 288 fiber. Just looking at the cross section, the couple things that will stand out is on the top cable, our standard dielectric. Just in the picture, you can tell that the jacket's going to be a little bit thicker. The main reason for that is because in that duct cable, the jacket is what's giving the cable its main pulling strength to be able to give it that 600 pounds of pull strength to be able to pull through the duct. Since on the micro cable or the blown cable, we're blowing that in, we're not pulling it. We don't need as thick of a jacket on the outside to have to be able to pull it through. So the biggest difference is, again, on the dielectric cable, the plain duct cable, we're at a 0.791 inch outer diameter. But you drop down to the blown cable and we're 0.374. So we are less than half of the outer diameter of a standard cable. So looking at just our cable itself, the thing is with this cable, because it is such a smaller cable, the mechanical characteristics overall are very low. We don't have near the crush rating out of a blown cable that we're going to have out of a standard cable. Again, because it's a thinner jacket. So what we're going to do is we're going to try to achieve a defined stiffness of the cable that's going to give us the maximum blowing length. And so what we're going to do there is we're going to play with a couple different materials on the outer jacket, and then we're going to combine that with the use of our central strength member in the diameter of that FRP. So really, those are the only two things that are going to give this cable its strength and its mechanical characteristics. It is for all intents and purposes, it is a very basic cable. But again, we'll dive into how we can manipulate this to still give it the ability to hold up and to do what we need it to do. So we mentioned in blowing, the great thing about it is we lower the friction right between the cable and the inside of the duct bank. What we can also do, and what we do in the design of the jacketing, is we can use different material that's going to try to lower our minimum friction coefficient as much as possible. Yeah, a standard cable is typically going to run with a medium density polyethylene or an MDPE. What we're going to do on a micro cable is we're going to bump up to a high density polyethylene, or we'll use a polyamide or a PA is what I'll probably refer to it for the rest of the presentation. So we're going to go with those two types of material to help lower the friction, again, between the cable and the inner duct bank. The other thing that we need to do is also need to look at the diameter of the cable in relation to the inner diameter of the duct. Ideally, what we want is we want the outer diameter of the cable to be 50% of what the inner diameter of the duct is. So if we've got a duct bank that's 1/2 inch inner diameter, we want that cable to be 1/4 of an inch outer diameter. You do have some wiggle room. It's definitely not an absolute. You don't want to go above 66% in terms of the ratio of the outer diameter to inner. And you really kind of on the flip side, you don't really want to go too much below 35% either. So anywhere in there, you're typically going to be good, but this will also affect, again, how far you can actually blow the cable and how far out you can go. The thing is, if we have too low of a cross section, what's going to happen is we're going to reduce the air pressure, but also it's going to give, because we're reducing air pressure, that cable is kind of, as you get pushed far enough into it, can almost form a little bit of a wavelength, kind of a shape inside of the duct. So now you almost kind of start bunching the cable a little bit because you're trying to push it from one side, but that airflow isn't able to carry that cable down the rest of the duct. Flip side, if we go to too large of a cross section, now we just essentially don't have enough space for the air to fit, and we're going to ramp up the amount of times that cable is going to actually touch the inside of the duct. Again, more friction, less distance to blow. All right, so now we'll look at essentially what I'll call our 3 main flavors of cables in the blown-in family. So we're going to have our central tube design, which again, you're going to have 1 buffer tube in the center of the cable. You're going to have 24 fibers max that you can fit in that design. From there, we go to the traditional multi-tube design, which is going to be what's a lot more common. But we've got our multi-tube 12, which is 12 fibers per tube. And then our multi-tube, our MT24, which is 24 fibers per tube. A lot of that's preference in terms of what you want to go with. 12 fibers per tube is going to be what's really the standard, at least for a fiber to the home build. The 24, if you do go up to a higher fiber count, a lot of times you will have to go with 24 fibers per tube, and that's mainly just going to be because of space limitations. Now, some people as well, I know ribbonizing fibers is becoming a lot more popular. So again, depending on kind of your preference and what your layout is, if you just have a long run, you're getting from point A to point B, more of like a long haul type of provider, going with the 24 fiber per tube may be something that you're interested in. So now within the multi-tube designs, we can break those down a little bit further. And these are going to be essentially the same, either between a 24 or a 12 fiber per tube. So mainly we're going to run with a 250 micron fiber. That's going to be, we'll kind of call it the default selection, if you will. If somebody just calls and says, hey, I need a micro cable, it's more likely going to get designed and quoted to you with a 250 micron. HDP outer jacket, again, I'd say probably is going to be along the lines of more common in regards of what you're going to see. So again, multi-tube, 12 or 24 fibers, 250 micron fiber, high density polyethylene outer jacket. From there, we can stick with the same 250 micron fiber, but we can drop down to our PA jacket. Now, what that'll do, and I'll bring up some differences here in a few slides that kind of break down the differences. The great thing about a PA jacket is we can actually run with a thinner jacket just because of that type of material. So we can drop our diameter size down a little bit just by going with a PA jacket compared to an HDPE jacket. Now, if we wanted to continue to drop our diameter of the cable, what we can do here is we can combine a PA jacket, but go down to a 200 micron fiber. So that's going to drop our buffer tube size. And again, paired with our PA jacket, which is going to be a thinner jacket. Again, we're still just continuing to shrink the outer diameter of our cable. And then if we really want to push it down, we go to our reduced design, 200 micron fiber, PA outer jacket. But what we're going to do here is we're going to limit the buffer tubes and the fibers in the buffer tubes. And again, and the main point or purpose of this cable is just to reduce that outer diameter. So we are going to be limited with the amount of fibers that we can use in this design. And then last, our central loose tube design, again, single buffer tube in the center of the cable. Again, very much limited in terms of how many fibers, because you can only go up to 24 fibers, again, since you do only have that one design, or excuse me, that one buffer tube. All right, so what are the differences when we're looking at all of these? So again, yeah, this is what we've got here is this is the rundown in the order of the slides that we just went through. So starting with our 250 micron fiber HDP outer jacket, all the way down to our central loose tube design. Each step is just dropping the outer diameter of the cable down to its lowest, basically the lowest that we can go. So with the 250 micron fiber HDP outer jacket, you can see we're between 0.22 and 0.44 in regard to the outer diameter. Now, simply dropping it down to just the PA jacket, we're going to drop a couple hundredths of an inch off of that OD, or roughly about half of a millimeter. Now, again, what you can see is when we pair that PA jacket with that 200 micron, that's where we do see a significant drop, or a much more significant drop in the outer diameter, going down to a 0.177 to a 0.366. And again, just continuing that down all the way down to our central loose tube design, where you're basically potentially less than a tenth of an inch for an outer diameter of the cable, which to me is just absolutely mind-boggling, having fibers in something that's just that small. But it's absolutely possible. And and maybe in your network you might come across a need for something that small, and there's an option there for you. So looking at the differences between the 200 and the 250 micron fiber. So what that does is it mainly, and the reason that we're able to contribute so much to the diameter of the cable, is we're able to use a smaller buffer tube. So we're going here from a 0.055 inch buffer tube to a 0.047, which it's not a huge difference, but when we start getting up into very high cable counts, that's where that small difference between the buffer tube is going to make a sizable difference in the outer diameter of the cable itself, right? So on a 288 fiber design, just by going to a 200 micron fiber, we're going to drop the outer diameter from a 0.374 to a 0.331. And then from there, you can kind of continue just to imagine if you're needing to run a 432 cable, right? If you are 432 fiber, if you need to continue to ramp up and you're in a position where you are limited for space, again, this really just gives you another option of which way to go with the network. So now when you are looking again between the two, I mentioned that the 250 micron, that's going to be more or less your standard. That's also going to be your lower priced fiber as well. If you're in an area where you're building fresh and there are no limitations, you're not you can plow or trench however you see fit. If you're not trying to fit duct into pre-existing duct that's already in place, 250 microns is going to be the way to go. Again, if you are stuck, you've got a strict diameter limit. I mentioned if you've got pre-existing duct that you've only got a limited amount of space to put a micro duct through, you may drop down to that 200 micron. So HDP and PA, right, our high density polyethylene and our polyamide. I mentioned HDP is going to, for most people, is going to tend to kind of be the default. And that's for a couple of reasons. One, the price is lower. However, the density and the hardness of the PA is a lot higher. What that means from a workability standpoint is the HDP is just a little bit easier for the technicians to work with and to handle. So from a preference standpoint, people tend to go that route. However, again, that we talked about the thickness because of the density and the hardness and the strength of the PA, we can get away with a smaller thickness of a jacket and still keep that same tension, still keep that same strength on that cable itself. So again, if we're in an application to where it's a fresh build, you're going into a neighborhood and you've kind of got your pick of what you want to go with, the HDP is going to be a good option there. And again, if we're in a place where we're going into existing conduit, existing infrastructure, and we've got strict limits on what we can do, the PA is going to be your best option there. Now, the biggest difference, in my opinion, is going to be the distance in which both of these jacket materials can be blown. So again, because of the polyamide, because of having a higher density and a higher hardness to it, you're going to have less friction between a PA jacket and the inner diameter of the duct. So which means you're going to be able to blow it further. So again, it's just another one of those things to keep in mind in regard to your particular network, what you're trying to do. You may not have a need to blow a cable 6,000 feet. So again, something else to keep in mind. Along the lines of looking at outside plant enclosures, if you can get your hands on a cable with an HDPE outer jacket and a PA jacket, I would definitely suggest that and have your guys work with it. Get their hands on it, and again, factor in the workability preference versus what you actually need from a functionality and a design standpoint. So the next thing, looking at going between a 12 fiber per tube or a 24 fiber per tube. I mentioned once you really start getting into really high fiber counts, you might have to go with a 24. But a 12 fiber per tube is typically going to be the standard. Now, one thing that's really interesting, though, with our blown cables is the cost effect of going with a 24 versus a 12 fiber per tube design. In blowing cables, 24 fibers per tube does have less weight, a smaller diameter, only in one case, and that's with our 144 and our 192 fiber designs. And the rest of our designs, a 12 fiber per tube is actually going to give you a smaller diameter and is going to be more cost effective, which is, again, it's not, that's not going to be traditionally the same with your standard duct cable. Usually in those cables, if you go with a 24 fiber, you're going to lower the diameter and you're also going to lower the cost. But again, with micro cable and what we're having to accomplish and how it affects the design, but still keeping up with that hardness in the stiffness of the cable. And I say stiffness, but really the stiffness and the strength of the jacket. It just so happens that those two designs are the only two, the 144 and the 192, that do present you a more cost-effective option. So, again, I mentioned earlier, we were talking about micro trenching, right? And being in kind of some of those maybe higher end neighborhoods that they don't want to see stuff. They don't want to see cables, really, to me, it's, the great thing about this, you can avoid, what we call, sky spaghetti. This picture on the top right, you've got power poles that have got their power lines on it. You've got, maybe the utility has already got their, some ADSS cable that they're running. Then you've got multiple lashed cables and just, really just kind of a sore site and just multiple cables kind of just taking up a lot of space and, call it kind of, polluting your view to an extent. The other thing too to take into account when you're looking at this is every time you add cables and you add more cables to these poles, you're adding the weight of the pole. You're adding to the weight and the that's being impacted on the pole. So potentially down the road, that could create issues in terms of the poles, needing to go replace all those poles so they can take the load from all of those cables. The great thing with micro cable is again lowering the footprint. It just gives you a much cleaner overall visual appeal. going back to the vaults and the pedestals, everybody's seen in in your yard and your neighborhood, you've either got a vault that's in your yard and it's ugly, it doesn't look good, or you've got the pedestals that are sticking up above the ground. But again, the great thing with these cables is because of the smaller footprint, now instead of having that 24 by 36 vault that's sitting in between your property and your neighbor's property, that could potentially get dropped down to something like a 13 by 24. So again, it's just, I think in closing, it's a fantastic way to build out a fiber network if it makes sense for your particular build. Again, you're going to lower cost because you're lowering the cost of the cable, you're lowering the cost of the splice enclosures, you're lowering the cost of the pedestals. But again, you're also lowering the cost of the install because now you're able to blow that cable so much faster. The cost of installing that handhole, the cost of installing a 30 by 48 vault, I'd say roughly is between $750 to $1,000 to put that vault in the ground. But if you can go with a micro cable that can now go into a 17 by 30 or possibly something smaller, now your install cost in that one vault is maybe $300, $350, right? So, and then then just the cost of the material. So if we take that, what's potentially ends up being a $1,000 to $1,500 savings at every single location you've got a vault, that's going to add up. And then also you're going to have customers that are going to be a lot happier because they're not having to walk out and see these monstrous pedestals in their front yards or walk out and see another cable getting hung up, running down the road. So again, that covers it in terms of the in terms of the webinar. I want to thank everybody for joining. I appreciate your time. Hopefully we can talk about this a bit more often on the road. If you've got any questions, I guess I'll go and open it up to everybody else and see. Let me get our chat pulled up here. All right. Anybody have any questions? Yeah. So as the webinar page just says we'll send out a link to the test after this. It'll be sent out in a follow-up email. If you do have questions, again, even if you think of something down the road, feel free to reach out and let us know. All right. Well, again, use the if you've got a question, use the chat function. I'll go ahead. I'll hang around here for a few more minutes if anybody thinks of anything. And but if not, again, appreciate everybody's time. Thank you for joining, and we'll be sure to keep everybody posted on our next webinar series. Yeah, thank you. I appreciate it. Thanks for joining.